Hey, 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 here we are again with Math with Zord, section 3 now, talking about polynomials. We've moved on, we're growing up, getting past the little tiny monomials, and we get to start combining them into polynomials. So let's go ahead and get started. You'll see that this is a short section, it's just the front side of a page, but there's a lot in it that you need to get, so make sure we're paying attention and listening, Ashton, not listening to your music, listening to me, so that way you can hear everything I have to say. So we first have to define what a polynomial is. It's any monomial or sum of monomials. So several monomials added together. We'll do a couple examples here so you can see a monomial is just something like x, one variable. A binomial, which is a form of polynomial, has two nomials, hence the term binomial. A trinomial would have how many terms? That's right, Emma. It would have three terms. X squared plus x plus 2. Something like that. Another quick example. 4y is a monomial. 4y minus 8 would be a binomial. 4y minus 8 plus 3x would be a trinomial. It has three terms. And just one more example, negative 5x cubed, monomial. Negative 5x cubed plus 2y squared, binomial because it has 2. And the trinomial, we'll say, is negative 5x cubed plus 2y squared minus 4z. So you can see it doesn't matter how many different variables there are, x's, y's, w's, whatever other letter you want to use. What matters is the number of terms in between there. There's three trinomials, 1, 2, 3, 2 in a binomial, and 1 in a monomial. You can have more, as we'll see later. We'll get up to some with 5 and 6, but they don't have any special names. They're just called polynomials. Okay? So, first example here, I want to write a polynomial to represent the area of the shaded region. Now you might be wondering, where's the shaded region? Well, here it is. I have a rectangle there. I have a circle in the middle with a radius drawn straight down. Okay, I'm going to call that radius C, and I want to call the length of this side B. Then we're going to shade in this region over here and this region over here. The circles do touch the tops and bottoms of that rectangle, so there's no space in between there. And what I want to do is I want to find the area of that shaded region. Okay? So the first thing I'm going to do is set up in words what that means. So the area of this whole thing, if we think about it, is I have this rectangle, and then sitting on top of it is a pizza or a piece of paper, whatever you want to think, some sort of circle, a pie, and I need the area that's outside of that. So if I take the area of the whole rectangle and subtract the area of the circle, that's going to give me what's left over here. Okay? So the area of a rectangle, I know that is length times width. I know the area of a circle is pi r squared. Now the last thing I need to do is fill in the length, width, and the radius with whatever the letters are representing. So my length of my rectangle, as we can see here, my length is b. My width. Okay, here's where we need to think a little bit. I have this radius here, c, that's cutting my circle or my rectangle in half. So I can know that this length here is c, and this length here is c. So this entire length is 2 c's minus pi, and I already said that my radius was being called c in this example. So the final answer is going to be 2bc minus pi c squared. Okay? So you're not finding anything, you're just writing a polynomial that would represent what the area is. And then you can just fill in the radius and fill in the length to figure it out. And we'll be doing a lot of those with different shapes, different figures, and things like that in class with practices and stuff. So make sure you figure that out. Now, the easier part of this is just writing polynomials. Okay, polynomials are typically written in a descending order by their degree. Okay, and the degree of each term is determined by the largest exponent. Whoa, I don't know what that was. Try that again. Exponent in that term. Okay, so I look at these different terms. This has a degree of 2 because of the exponent. This has a degree of 6, a degree of 3, and when there's nothing written there, it's a degree of 1. So I need to write the term with the largest first, which means I'm going to write negative 3x to the 6th first. Always remember, the sign that's in front of your variable is the sign that goes with it. So the negative 3x to the 6th. Then I'm down to third, so it's a positive x cubed, a positive 4x squared, and a negative x to the first. Okay? So there's my polynomial in descending order, 6, 3, 2, 1. And one more example, and we're done with these notes. This was short. I take a look here. I want to write it in descending order according to my x's. So this doesn't have any x's. There's no variable there with x's. This has a degree of 2 because my x value is 2. Here, if I look at my x, it's a 1, and here it's a 4. So the first thing I have is negative 9x to the 4th y. Okay. Then my next biggest x is going to be ax squared. I see that that's a positive ax squared. Next comes this big term with my exponent of 1, and that's negative 2a cubed xy cubed. And then the last term I have is a to the 4th. Okay? So we can look at the x's, 4, 2, 1, none. Okay? I hope that makes sense. I know that second part was much, much easier than the first. Please ask me questions on that first part. I know there's going to be a lot of questions when you go to do them in the homework. Please pay attention to that. Rewatch it as many times as you need to figure it out. Okay? You always want to do the area of the bigger object minus the area of the smaller object to get the shaded regions. Okay? And you'll see in the homework that sometimes that's a circle minus a rectangle, or a circle minus a triangle, or a triangle minus a circle, depending on how it's made. Okay? So we'll see you in class. Good luck. Bye.